Now that we've imported the records for the three collections, we're going to go ahead and go through an introduction to Mongo and how to navigate and interface with MongoDB. So, in our last video, we went to the virtual server. We'd opened up two windows. One was at the system prompt, and one we logged into the Mongo prompt by typing Mongo. We can close out the system prompt. We don't need that no more. Actually, don't close it this way. Go ahead and over here type exit, and then you can close it out once you're at your Mac prompt. So over here, you should have typed Mongo at the Ubuntu prompt and then gotten a arrow like this. And in the last video, we imported the courses, locations, and JSON user files, JSON files, into three collections. So now we're going to go ahead and actually see the data. So once we've started up Mongo, if we want to list our databases, we can go over here and type show DBS. And that'll go ahead and let us know we have a database here called ADB. If you recall from the import, we imported everything into the ADB database. Now if we want to use the database, we type use ADB. And now we're actually attached to the ADB database. That's basically the equivalent of starting up SQL Pro and then from the drop-down selecting which database you want to talk to. So now that we're in that database, the next thing we can do is go ahead and show what collections are in here. So if we type show collections, now inside of the ADB database is the courses, location, and user collections which we imported. To go ahead and see what's inside of those, in other words, in SQL we would open a table and see the spreadsheet view of what's inside of it, the data in the table. In Mongo, what we need to do is do DB, which stands for database. They group commands. So most of our commands are going to start with DB dot collection name. So I'm going to go ahead and say from the user collection dot, I want to do a find. And you'll notice I end find with an open close parenthesis. That is because find is a function. So we're telling it that we're going to run a database level command. We're going to the user collection and run a find. And if we do that, it just spits back a lot of data and says type it for more. And I could type it, but this is a little bit hard to read, to say the least. So I'm just going to hit enter a couple times. It's not running anything. I'm just giving some space so we can see the command differences. If I hit the up arrow, it'll pull back the last command. And on the end of that command, after find, I'm going to put dot pretty, which is also a function. If you recall in SQL, we had an order of operations, which meant how the SQL statement ran. In Mongo, that no longer applies. It's always left to right. So what we're going to do is we're going to run a database level command against the user collection. We're going to do a find, and then whatever the output of find is, we're going to put it into the pretty command. And what that does is format the data coming back so it's readable. And here we can see we have an ID, a first name, a last name, a username, a date of birth, user status, user type, created date, age, height, color, and so on. And each one of these is a separate document. This is comparable to a row in a table. So, whenever data gets stored, a couple quick things. In SQL, we were able to choose which column was the primary key. And in Mongo, we don't get a chance to do that. The underscore ID is a required field for every document. And if you don't insert it, meaning if when you create a new document you don't give it an ID, it will assign it an ID that looks like this. And it's a great big random object ID. You cannot delete the ID field, nor can you update the ID field. It's just an ID field. That's really it, but you can't choose it. This is the primary key. But here's the wonderful thing. There are no foreign keys. There are no joins in Mongo. So let's move on. Databases and collections. So databases are similar to databases in SQL. We have a database, we call it ADB, or maybe we call it, I don't know, Clint's Comic Shop, or whatever we want to call a database, we can go ahead and call it. But in there, it has its own files, meaning on the file system somewhere, there's a group of files that store the data for the database. And in there, if it was a SQL database, there's tables. In a Mongo database, there's collections. So they're similar. But the one thing about a collection as opposed to a table is a table we set up a spreadsheet structure, which means every row in that database has the same columns. And you know what? I'm just going to start up SQL Pro for a moment so we can take a look over there, and it'll be attached to my VirtualBox. And if I go to that ADB database and look at the customers, when we create the customer table, what you'll see is every row here has a customer ID, first name, last name, username, password. But MongoDB is something called schemaless. Here's what that means. Look at these two records. You'll notice the first one has 1, 2, 3, 4, 5, 6, 7, 8 fields. But the next one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 fields. What schemaless means is that there's no set structure. So this document has more fields than this document. Another note, MongoDB is extremely case sensitive. What I mean is I can have two fields here, one called age with lowercase, one called age with uppercase, one being a string and one being an integer, and it will accept it in the same document because it considers it to be different. So be very careful with that. It also is case sensitive in your searches. So later on we're going to see if I do a search for last name equal to Osborne, if I search for Osborne lowercase, it won't come up. We have to go ahead and actually search for the exact case. So again, MongoDB is extremely case sensitive. But let's go ahead and actually start creating some data. And one thing you're going to notice quickly is MongoDB looks a lot like JavaScript. So if you like JavaScript, you're going to love this. I'm going to go ahead and just close out SQL Pro, and I'll leave that open. So if I want to create a new record, I could declare a variable called x, and I'm going to go ahead and set it equal to this. So I'm going to open close squiggly brackets. I'm going to set my ID to 100. Let's see what we got here. My user type equal to, and it, by the way, single or double quotes, it doesn't make a difference. Client, I'm going to set the first name equal to, who do we got here? John Doe. John. And the last name to Doe. Now, when I do that, it just declared X. It didn't save any data, it just declared a variable. So I can retype in X, and it will regurgitate back to me whatever is contained in that variable. Now, if I want to save X, I have to run a database command. So I say db.user, again, user is the collection, .save, and I'm going to pass X into the save command. And now when I hit enter, it's going to let me know one record was upserted. Upsert is an interesting word. It's a combination of the word update and insert. And what it means is one record was either updated or inserted. So it's kind of combining it as a count and saying one record was either updated or inserted or a combination of both. But that's one way to create a record. So we actually saved John Doe to the database. Another way to go ahead and do it is to run it all in line. And here's what I mean. I'm going to hit the up arrow, but instead of putting X there, I'm going to put the entire record. So here, I'm going to say the ID is 101, the user type, and again, this is case sensitive, is client. You know what? Let's create an error. I'm going to do it as a lowercase, so I can show you this later on. And first name was, it was James. and last name was Smith. By the way, I put additional spaces in here. That's just so I can tell the beginning and the end parentheses. Now, by the way, here's a little trick. Take a look at this parenthesis start. If I move my cursor, this part here, over to the end cursor, that first cursor here changes color. And that's just a way to match it. As well as if I put my cursor on this ending squiggly bracket, this beginning squiggly bracket changes. Just a little hint to help you write this. Okay, now if I hit enter, instead of doing it in 2 steps where we declare the variable and then save X, this just saves it all at once. Whether you use one or the other makes no difference, the data is still saved. One note though is that the ID has to be unique. Alright, next one. We started with the insert, so we can put data into it. But how do we, oh, sorry, first we started with the, actually the find, didn't we? We did the find, so we can get our data. We did our find pretty. Let's run the pretty again. I'm going to hit the up arrow a couple times and do the pretty. And again, we get a whole bunch of data, but I think we imported about 97,000 records. I'm actually looking for the couple records we just inserted. So what I'm going to do, and I'm skipping around from the slides, I'm going to issue this find command, but in here, I'm going to pass squiggly brackets to start off the JSON. I'm going to say where the ID is 100. And that's kind of like a where clause. So here we're saying do a find where the ID is 100 and then pretty it. So there is our John Doe. Or I could hit the up arrow and let's make it 101. And that tells us here's that James Smith. Now I'd like you to go ahead and actually do this exercise with us so you get used to doing inserts. So here's what I'd like you to do. In the user collection, I want you to create 10 new documents. 6 of the documents should have an age field. 3 of them should have a height. 3 of them should have an eye color. Any combination you want. All of the documents must have a user status, first name and last name. And 7 should have a user type of client, 2 admin, and 1 as overlord, and don't change the existing users. For the benefit of speed, I went ahead and created 10 save commands. And I have my overlord, my 2 admins, and all my clients. They're all active. I have Tony, Steve, Clint, so on and so forth. What you'll notice is some of them have an age, some of them have an eye color. Some of them have an eye color and an age, others have a height. Some have a height and an age. This is that schemaless thing where the records are not always going to be the same. But what I am going to do is copy this. And my recommendation when you're writing Mongo commands for the first time is open up, I use Text Wrangler. The reason I use Text Wrangler is because, remember that single quote issue we've been having when you copy? Even text edit will go ahead and try to turn them into apostrophes. If you use Text Wrangler or Sublime, either one, those will preserve the single quotes that you're looking for. But I like copying over the rows, the commands, and then changing the data. Now what you can do is copy them all, and you know what, I'm going to copy the first one just to make sure it runs. So I'm going to go over here, I'm going to paste it and hit enter, and it says one was and inserted. Great. So now I'm going to copy all of them. As long as they have a carriage return, meaning at the end of the line I hit enter, I can paste it, and you see it inserted all of them. So go ahead and pause this video and just take a few minutes and create 10 new users. You don't need to use the Avengers like I did. You can do whatever names you want. You can do whatever eye colors you want. You can do whatever ages you want. Just please go ahead and follow these constraints. And when you're done, come back and hit play. Okay, once you have the users all created, couple of constraints I want to tell you about. Up until now, I've used the word JSON, which is technically true. Everything we do in, almost everything we do in Mongo, like passing in these records, is JSON. However, they did an expansion on it. It actually will also handle something called binary data, meaning it'll handle a video file or an MP3 or whatever the newest audio film is. But audio files, they included all that, so they call it BSON. So it is JSON, JavaScript, object notation, but it also handles binary documents. And the only limitation, big limitation on that, is that each document must be limited to 16 meg. Now, binary files can get larger than 16 meg, but for text, meaning if I do one particular save, the amount of text between these two squiggly brackets, the beginning and the end, has a maximum of 16 meg. But if you've ever tried to type out 16 meg, it is a lot of typing in a lot of fields. So normally we don't hit that limit. All right, returning documents. If I want to go ahead and get some documents back and do a filter, I had shown you a little earlier that, I'll hit the up arrow several times, I can do a find command and pass it a JSON string, and that will filter it. So if I wanted to go in here, let's do this, and I'm going to change this. I want to say user type is overlord. And that returns for me Tony Stark. You probably have someone different, but you should have at least one overlord. I'm going to go ahead and do another one, and watch this. If I say client, I get lots of people. But if I change this to lowercase client, I get one, and I put this one in there intentionally. When you save your data, make sure you save it correctly, because if you have lowercase client and then uppercase client, it considers them different when you search. All right, this over here actually should be user type. Here we go. Besides that, let's do this. Let's do a search for client. But before we do the pretty, let's add on a sort. Again, order of operations is left to right. So do a find for all clients, then do a sort on that data, and then pass it to pretty. And the sort also accepts a JSON string. And let's sort by the first name field. 1 is ascending. So if I run that, we should see first name of Aiden. If I want to go ahead and rearrange that, I could put in here a -1, and that means descending. So now we get the Zoe's up on top, and I think it displays the first 10 records and then says hit it for more. That is only a thing in this tool, so that way it doesn't run up all 100,000 records. For the most part in Mongo, +1, when you do a sort, 1 is negative, -1 is descending. You can pass in 100, it'll still do it ascending, but just stick with +1 or -1. I believe if it's a 0 or positive, it's ascending. If it's a negative number, it's descending, if you actually want to do that, but just stick with +1 or -1. However, the sort order is a little bit weird. We go through the nulls first, and then the 0 through 9, capital, and then lowercase. So, let me go ahead, and I'm going to sort, but I'm going to sort by user type. And over here, I'm going to get rid of this filter. So instead of finding, we're going to find all records, sort by the user type -1. So if I do that now, we're going to see, and I'm just going to scroll up to the top of the command. Since I said descending, -1, we're going to get the lowercase first and the uppercase second. Look here, client with a lowercase comes first, then this is weird, then comes overlord, then comes client, and then all the way down at the bottom will be administrator. Let's go ahead and do another one. Let's go ahead and sort, but let's sort by age ascendingly. And what we'll see here is also going to be a little weird. The first record, we said sort by age ascending, has no age. The reason is nulls are used obviously to fill in missing data, there is no data for age, so these people come first. However, if I say sort by age descending, what we get now is Nick Fury, who's 55, who is the highest, again, numeric age, because we're doing it descending. And then 49, and then age of 47. So be aware of this. There's also a little problem with doing all that. I'm going to go ahead and create one user here. And we'll go with James Bond. And I'm going to say he's about 50, but I'm going to put it inside of quotes. Because we don't have a schema, we don't declare that age is a integer or age is a string or something like that. What we can do is it takes it as it saves it. So because it's inside of quotes now, it's going to save it as a string. Well, what does that mean? Okay, I'm going to sort by age descending. Well, what you'll see is because we said descending, strings come before numbers. So age of 50 as a string will come before age of 55 because 55 is a numeric. So the sort order is a little interesting at best. So please be aware of that. Okay. A couple of other little functions we can do. Limit, skip, and count. So if I go ahead and I do this find, and let's make it nice and simple. I could say limit, and this is one of the very few functions I can pass in a numeric instead of a JSON document. I'll say limit 2. And what that will do is limit it to 2 records. Limit has the same effect as limit in SQL. We can also go ahead and say skip to limit 2. What that does is it's still going to go ahead and do the same order. We did a find, so it's first come, first serve. But it's going to skip these 2 records, Jane and Sally, and it's going to give us the next 2 records. If you've ever heard of pagination, whether you've heard of it, you've definitely used it. It's when you go ahead and have a page, maybe it has 10 records, but you're looking at 1,000 records. So you have a button that says next 10, next 10, next 10. Well, you could put in here how many records you want to skip, and then how many records you want to show. So if I was on page 1, I would just say limit 10. But if I'm on page 2, and I'm showing 10 per page, I'd say skip the first 10, show me the next 10. And then for the third page, I would say skip the first 20 records, show me the next 10. And 30 and 40 and so on and so forth. So skip can be used with limit. The other one, let's get rid of all this. I'm still going to do a find in the user collection, but I'm going to do count. And it's not count star, it's just count. And there's 97,317 records in that collection. All right, here are some other ways of doing comparisons. We can do greater than. So in here, we're going to get where the user type is client. You probably want to make that a capital C to match with the database. And we're going to say where the age is greater than 22. We could also say GTE for greater than or equal to. You can also do LT or LTE for less than or equal to. But this will not only work on numeric fields, it'll also work on string fields. Ands, by the way, are done with just commas. So I'm going to do a find. And in the find, I'm going to give it a filter. So this is like a where statement. And I'm going to say where the first name is Tony and last name is Hillman. And that should return everyone we have lots of Tony Hillmans in here. So whatever script I ran created lots of them. But that's how we do an AND. To do an OR, what we can do is a little different. Let's go ahead and do an OR. The way to do that is, of course, it's got to be a JSON document. And then over here I'm going to say OR, and then I pass it an array. And each value, each document in here, so I could say where the age is 50, or the last name is Bond. And you know what, 50 is not let's go like a younger one, let's go like 22. And if we take a look, you know what, let's add on a pretty. We can see we have age Bond, who is 50, but we also said or the age is 22, and both of these, Kevin Smith and Peter Parker, are both 22. Again, it's looking for 22 numeric. If I was to change this and put quotes around it, like so, we're probably not going to get those, because now it's looking for age as a string. So it's not only case sensitive, but it is type sensitive as well. And here's some other examples of how to use OR. All right. If you recall in SQL, we could do a search using like. So if I say where first name like J and a %sign, and these are the wrong quotes, Word document did that. What we're looking for is anyone whose name starts with J. If I go ahead and I say where first name is greater than J or less than greater than or equal to J and less than or equal to JZ, basically this is J and a null, and this is J and a Z. It's looking for anything that's J and anything after it. So it will go ahead and produce the same results as here. I just found a typo here that there's a users here. It should be user. But that's one way of doing it. However, the preferred way is to use something called a regular expression. So I'm going to do this with you. If I do db.user.find and I pass it a document, and I want to say where the last name, and I'm going to give it brackets like so, and I'll say $regex, and we have to pass it a regular expression. Again, single or double quotes don't make a difference. And if I say caret, which is the shift and the 6, and let's look for a capital B, it should return anyone whose last name starts with a capital B. And if we look here at last name, everyone getting returned, their last name starts with a capital B. I could go ahead and type more. I could say BJ, and I'll get back everyone whose name starts with a BJ. For regular expressions, here are the two I use the most. Caret and a letter will follow anything that starts with that letter, S in this case, followed by any number of characters, just like we did over here. If you want to find something that ends in a letter, it's that letter and a $sign. So if I want to find everyone whose name ends in ing, I would do ing, but I would put a $sign at the end of it. And now everyone's name returns ending in ing. Lastly, if I leave off both of them, the $sign and the caret, this is now anyone's name containing this. So it doesn't matter if it's in the middle, the beginning, or the end. That's anyone's name containing ing. So regular expressions are extremely useful, and they've been incorporated into MongoDB quite a bit. All right, next lesson. Next one here, filtering documents. Sometimes we need to filter a document and give it a type. So here I'll say filter where the first name $type : 2. The only thing you really need to know about this is a 1 and a 2. 1 is a double, meaning a numeric value. 2 is a string. These rest we'll be using later on, but I rarely use them. So this is just a way of finding out what type something is. So if I want to go ahead and find whose name is incorrect, I could say, let's find where the age, $type, I want to find out where the age is a string, which would be a 2. What we'll see here is that brings back James Bond because his age is a string and 2 is a string. We can also check to see if a field exists. So if I say age $exists : true, it'll only return the records where the age field does exist. And if you say height exists false, we're only going to return the records where the height field does not exist. Let's see what we can do here. We can, of course, do a find and then do a sort and do a limit. We did that a little earlier. But that returns an entire list of documents. We're now going to talk about how to actually update a document. We're getting through CRUD now. So we've done insert and we've done select, which is find. Now, if we want to go ahead and find or update a record, I could do X, and X is just something I'm picking. It could be anything. And I'll say db.user.find1 with a capital O, F-I-N-D-O-N-E. And I can run it like this. But I'm going to get specific, and I'm going to say where the, last name is Bond. And it comes back and it tells me it returned this record. Find one, regardless, will always turn a single record. But what it does is, instead of just listing them, it loaded X with that value. Why is this important? Well, if I want to fix age, I want to make that a string, an integer, and from a string, I could say x.age equals 50. And now, when I type in X, it's updated. I could also say x.height is, we'll say he's 64 inches. He's a tall guy. And then I type in X, and there's height. What I'm doing is I pulled the entire record back, and now I'm modifying it manually. This doesn't change it in the database until I save it, though. So I have to do db.user.save X. Now here is something interesting. Save is both an insert and an overwrite. Let me say that again. Save will either insert a new record if the ID is unique. However, because I pulled it back, we know that ID already exists in the database. So when I saved it, it went and found this ID and said, okay, it already exists. Overwrite the existing record with that. So if I go back now and I say, find me, and let's change this. I'm going to say, find me where the last name is Bond. We're going to see that he now has the age and the height, which I fixed earlier. So again, I used find one to return the record, and that should be a capital one. Then I modified the record locally by typing x.age, x.height, and then I did a save over here to resave it. And since this ID field already existed in the database, it overwrote the record, and now we have the correct data saved. And here's an example where I do a find one, I set the age, and resave it. Deleting documents, we're almost done. It's very simple. It's db.user, the collection name, .remove. Don't ever run db.user.remove. That will remove all documents. You either want to put a filter or you want to put just one in it at the end of it to remove just one document. So if we want to remove Bond, here's what I would do. Run your find first. It now returns one record. If I know that works and that's the record I want, I can change this to remove, and now he's gone. Important to know, there is no undo. There is no back button. There is no I'm sorry. Once you hit that button with the enter key with the remove, it's gone completely, and there is no way to get the data back. This is a way of saying the first argument here is the filter. So here I said last name of James Bond. Actually, let's do something here. Let's say the last name is Osborne. Osborne. It's a lot of Osbornes. Let's just say for whatever reason I want to delete one Osborne. I can say just one. And by the way, that :1 here is just a placeholder. It requires JSON format. I could say : banana cream pie and it would still work. Okay, so if I do that and I change this to remove, it says it removed just one. Now, if I had run remove without this, if I remove this just one, it would have removed all of them. So sometimes the just one is a good safety if you know you only want to remove one record. I wish the default was opposite, that you would have to say more than one to remove more than one, but that's not the case. Just one's just an added feature on that. Okay. We're going to continue this in the next security in the next lesson. So for MongoDB at this point, you should be able to do what? Insert, update, delete, and select records. So that concludes this lesson.